All right, so we don't have much time, and I have to catch a plane right after, so I'm going to be on time. So today I want to talk to you about some of the work we do with Delta Lake. Not the kind of typical, asset stuff or Unity catalog, none of this. I'm going to talk about something that is kind of a bit besides of it. Just to give you some small context, I actually work for Maersk in Denmark. We are one of the largest shipping companies in the world. I work specifically in the Transported by Maersk section, and so the data platform that I lead and that I work with is essentially considered with like the past of ships going from A to B, and then where they are now, and then where the future is, right? So we have data about the history, we have data about the current state, and we have predictions about the future. And taking diversions, for example, if you remember Suez Canal being blocked right now, that's a big diversion. That's a big problem for our company. So kind of doing that efficiently and having reliable service for our customers is important, right? So it's important to have good intelligence in the operations of Maersk, and that's exactly what we're doing. Today we have more than 20 machine learning products in operations. So some of them are decision products actually. So we're actually aiming to do zero-touch logistics. Of course, that's hard because we're a company that's 110 years old. So we have every kind of technology from on-prem, DB2, Oracle, up to Confluent, Kafka, everything. So in that kind of heterogeneous space, we're moving and trying our best to help the company be profitable. So data platform essentially consists of mostly open source. So we use open source Spark or Kubernetes and Blob. We use Apache Flink open source. We use Delta Lake open source. We have a lot of pandas workloads, especially for machine learning. We actually use Unity catalog as a layer on top to be able to do like explorative stuff. We use a lot of structured streaming. And of course, we also do a lot of simulation, right? So as you saw before in the slide, when we make decisions on where we reroute ships, we need to kind of figure out what's a good decision, right? Is it costly for us? We also need to reposition empty containers, right? So because in Asia, there's more export than import, so we constantly need to bring back containers to Asia. And how we do that exactly, there's billions of dollars a year of cost. So optimizing that is, of course, one of our big use cases, among others. So the beauty of Delta, to come back to my talk, is I think there are lots of things that's beautiful about Delta. I just list a few here, and one of them is that there's no extra components needed. You can use it like Parquet mostly, right? Of course, it's Parquet under the hood, right? But you don't need to have extra components. It's a protocol that works in many engines, and I'm going to show you that we're actually using it for different stuff. It's super easy to set up and test, also locally, and you have rich metadata. And the metadata is what I'm going to talk about today because you know everything about Delta Lake. You've been at this conference now for 2 days. You heard probably 20 talks about Delta Lake and Databricks. So I'm going to talk about the transaction log and how we use transaction log and the versioning of Delta to do some cool stuff with data quality and observability for data. All right. Well, and also efficiency, actually. So the first one is about efficiency. So run jobs only when needed. What does it mean? It means that when you're running, let's say, batch pipelines, and you're just running them on cron, it might mean the data you're running on is the same as yesterday or the same as an hour ago. So you're doing work, again, for no reason. Right? You're spending money for no reason. You're spending compute and storage for no reason. So one of the things you can do with Delta is that you can actually make it so that your pipelines only run when data changed. So we have an in-house scheduling system, and that is, that's rather old, but it's nice and flexible, and it's also reactive. So it's not like Airflow. It's more like you write a job and you say, sources 1, 2, 3. Whenever a source change, rerun the job. That's roughly how it works, right? With lots of other stuff. But that also means that it just runs whenever the upstream job ran. And then when we added Delta Lake, we could actually make it so that it looks at the metadata of Delta to figure out, is the metadata new? Is there a new write? Is there a new streaming update? Is there a new merge? And only if that happens, then we run. Otherwise, we don't, right? So we save some money. Of course, that's not super easy, right? If you look at your Delta transaction log or your history, right, you have optimized commands, you have vacuum things that also make entries. So you need to have quite some control over what you're doing in order to do that, because you don't also want to just constantly read Delta. That takes a lot of time. And you also don't want to necessarily use Spark all the time to then read the history. So what we do is we actually, as part of our orchestration, we save the metadata about the version of every job. So our orchestration actually knows exactly which, if you have a data set, what exactly source data sets were and which versions they were to be used. So we know the exact provenance of everything. And so I have that down here. I hope you can see that. Like on the bottom, okay, this doesn't work, but on the bottom of the screen, you can see I wrote down some metadata, and so that's just to say, okay, it's saving the version of the actual Delta table, right? Version 3, 4, and then 4 in the third case where there's no new data, right? We're going to go through that in more detail now. So if we go from left to right in time, and let's say you have some Kafka. By the way, that's not Gen AI, that's me scribbling, right? So don't judge me. But let's say you're doing a micro batching from Kafka. Time goes from left to right here, and then this Delta table gets just appended every time, right? And so first time you have a version 3, then you have version 4, and then the third time when you're asking Kafka for new data, there was no new data, right? Fine. So you're staying at version 4. Fair enough. That's actually out of the box Delta Lake, right? When we then run a job, and let's say that job, down there, that has the previous version as a source. It says, okay, I have version 2. And then it runs and it says, hey, I have a new version. Great, I'm going to run because I used to have version 2. Now I need to run because the source updated to version 3. Fine. I update this. It's all good. I do the same thing again. Data comes in. I run. I upgrade my metadata. Right? Very easy. And I mean, all this stuff, of course, is not very. There's no magic bullet here. It's just to kind of show you, that you can do that with versions. But the next time you run it, there's no new data. So the orchestrator will say, hey, I look at my destination data, I look at my source. There is no new data. I don't need to run. And now you can imagine that, this is maybe just one Kafka topic, but we're having, in our situation, we have 20 different applications that depend on some of the data. A lot of the data gets fanned out into lots of different applications. So not having to run this is actually, quite a cost saving for us. So the quick story of this is that you can make smarter scheduling of jobs only when needed. In our case, we reduced the daily job executions by 10%. So we used to run around 30,000 job executions a day, and afterwards, 10% less. It's really great for structured streaming, and when you have slow changing data. So if you, of course, have data all the time coming in, it doesn't matter. But in our case, we have lots of sources that are, if you think about scheduling of vessels, we have 700 vessels, right? Those are sometimes really big, but of course the schedule doesn't change every minute, right? So you don't need to run all the time. So you can save quite a lot of costs. There are some pitfalls, though. You need to take care of vacuum optimized entries, and especially if data is really not changing for a long time, you need to make sure that you have the right retention settings and stuff. But once you take care of that, it's actually a nice feature. And of course, I completely forgot to say one thing here. All the projects I'm showing here, those are part of our skunk work, so where we have some time to just work on whatever, right? So these are just small, little, nice, beautiful projects that are not prioritized necessarily otherwise. All right, so that was the first bit. Only run jobs when you need to, so you can save money. The other one is write out and publish. And as you may know, Delta Lake itself doesn't have a write out and publish feature, right? So you can't commit something or stage something and then audit that and then only publish it. That doesn't really exist in Delta. But from where we came from, before we used Delta, we actually had write out and publish out of the box because we're using essentially naive snapshotting of data. And so we wanted to have the same for Delta as well. And so what you can do is, again, using metadata, in this case, again, it's our orchestrator that does it. You run a job, you commit the data. So now, let's say you go from version 1 to version 2. And then you will, in your metadata, say, okay, now I'm upgrading to version 2 if I actually pass the audit, right? So in our case, we use Great Expectations and Soda Core. And then it says, okay, this is the new version. So the reader that comes in next time will use the metadata and say, I'm going to take the latest version, version 2. But if it doesn't pass the audit, you're just keeping the version 1 in your metadata, which means that every reader that comes in will just read version 1, right? It will not actually use the new data. And then you can either roll it back, or you can accept it, or you can make a new override. That's up to the operator then to decide what's going on, right? And of course, you get an alert. So we're full alerting set up. I'm not going to talk about the platform that much. So you can do that with metadata as well. And that's quite beautiful because you don't have to do anything really, right? Like in the first example, it's just the history and the transactional that comes with Delta. That's nice, right? No extra tooling. It's just using metadata. And of course, these data sets, they get read by, as I said, pandas, we have polars, we run Spark, Flink. So it works pretty well, or it works actually extremely well. But of course, this is just in the batch mode, right? So if you're writing a full data set. But what happens if you're doing structured streaming? Structured streaming is not as easy or not as useful necessarily, because in structured streaming, let's say you're appending stuff, so you don't want to then always audit the full table, right? So you don't want to write like 10 new rows, and then you want to have 10 million rows that you're auditing. That doesn't really, it's not very performant, it's not very efficient, I would argue. So what you can do is you can just read the changes from the last version. So you can use the change data feed in Delta, turn that on, and then you can get the latest changes and only run the audit on this, right? So then you run on your increment, and you audit only the increment. That's great, right? Again, comes for free, no extra tooling required. You can do it with Delta Lake open source. So if you're wondering how to do this, I mean, it is. Hopefully, I can tell you it's very simple, or you can agree with me that's very simple. Essentially, you just turn on the change data feed for your Delta tables, because that allows you to always go back in versions, right? So you can say, oh, I want to have all the differences between version 3 and version 4, and that's what you then take for auditing, right? So you can have both. You can have the full batch write audit publish, and you can have the incremental write audit publish. And here I'm just showing you the code. So it's really as simple as a couple of lines of code. Enable change data feed, done, you're good to go. And then if you want to do the latest commit, that's kind of what you do here, right? You're just looking at, okay, just give me, give me the history, and then let's see, okay, when did I had a write, the streaming update, and then give me the stuff in between, right? So that's kind of nice, because again, in the end, you don't have to do anything as a user, right? It's pure Delta Lake that comes and does it for you. And you can just request that increment and validate that. Cool. And I'm going way too fast, obviously, because I really don't want to miss my flight. But then I have maybe more time for questions. So the summary of that is that write audit publish. I guess all of you know that. I mean, at least if you're doing data engineering, right? It's a great pattern to kind of prevent bad outcomes with data. So we use it a lot, not just for like bad data coming in, but also for forecasts. So when we do forecasting, our containers are on the water for like months sometimes. So we don't do real-time forecasting. It's mostly batch inference, right? But some of the stuff we are actually looking at, it's very sparse data. So it's easy to put out shit as a forecast. So we're trying to avoid that. So we're using that pattern there as well. And we regularly are saved by that pattern where we're putting out maybe bad things. Of course, again, for streaming, the more you go to streaming in real time, it doesn't really help you. So then you need to do something else. You need to do dead letter queues or something. But at least for structured streaming, it works quite well up to a certain size. All right, and the last bit is that we have one project where we're using essentially AutoML to detect streaming issues. So again, we're in a big company, 110 years old, lots of different sources of record, lots of different maturity in terms of data. Everybody starts streaming from on-prem to God knows where, and we're consuming that, and we have to make decisions on putting boxes onto ships, and that's really expensive, right? If we're making a bad decision on like putting 100 boxes on a different ship, that's costing us maybe $1 million if we're unlucky, and we're putting these things around the world. So mistakes in our case are really, really costly. So one of the things that we observed that happened in the kind of like this transformation of where everybody tries to go streaming is that people have degraded performance of their streaming processes, for example, or like of their outbound streams. And so you would see like a degradation of like, not enough data coming in from the booking system, right? But the booking system wouldn't know because they don't have monitoring or something. Sounds hilarious, but that's often the case in many companies. So we built a machine learning model that does it automatically. Because when you look at the data here, again, it's just pure Delta Lake, right? If you're looking at the history of data coming in, you see there's a strong pattern, right? There's a strong daily pattern and weekly pattern. And you can't just set a threshold and say, I'm expecting like 50,000 rows per hour every time, or like at least 20,000 or something, right? You can't really have a threshold here. It simply doesn't work, right? So that's not normally what you would do if you use great expectations, for example, you would set a threshold, you'll be good. But you can't do that. So how do you deal with that? Well, the answer is, as I already said, right, AutoML. So in our case, we really just used Profit, essentially. So we just grab the history data from Delta tables. We do that every day. and then we train the model on it, and then we predict the next 48 hours of like how we think the stream should process, or how much velocity we should have in those streams, right? And that's like a no-ops thing. So like whenever a person in our data platform adds a new stream, right, that's automatically generated, right? And there's automatically alerting added on this. So it's not that you have to do that. It's just that automatically the data platform takes care of that. So it checks then the amount of rows and alerts on that. And here you can see that in the Grafana dashboard. The green is the upper limit, yellow the lower limit, and it says somewhere there, orange is what we would expect from the forecast. Again, it's just a profit forecast, very simple time series forecast. And then the blue is what we actually get in. And we have, we have multiple incidents where we actually use that. So we're not stopping streams because of it, but we're using it to often debug problems that we're seeing in data where we suspect missing data, because how do we otherwise find missing data? It's tough, but this helped us a lot already. So yeah, opportunities here are that you get really great observability about your data, and essentially you have it's a way of like anomaly detection. Of course, it doesn't always work, right? Because you have, let's say, data that is slowly moving. You can't really predict that, right? You need to have some kind of volume that comes in to actually have good predictions. You might also want to take other things into account, like nulls and whatever. But here it's just like, again, pure Delta Lake. I'm running some AutoML on it, and I get a great result I get a great result in the end. So again, it's just profit, nothing fancy. Maybe now with Databricks and the AI function SQL, we should just do it in SQL. But let's see. As I said, low velocity is a problem, and structured streams with multiple commits is a problem. So if you're working with Kafka and you have colleagues who like tombstoning, you might want to make sure that you're properly doing like your calculation of velocity, because you get tombstones that you commit within the same microbatch. So you might get 2 tombstones and 100 rows, the other commit. So you need to take care of those things, right? So just in case you're thinking of doing that, beware. There are a couple of issues here that you have to sort out. And I don't have a thank you slide, but thank you all for coming, and that's it. Cool, thank you.